Hi there. Glad to be here and glad not to be alone actually this morning. So thanks for coming out. I'll have, maybe some people say it's sexy, some people see it as complicated, a ménage à trois. It's definitely three buzzwords that I hope that you're sort of familiar with, because in 20 minutes I cannot give you the basics of all three of those. So I'll try to focus on the combination of these. But first, just a little bit about myself. I'm Freddy. I was the co-founder and chief data officer of AnyBlock Analytics, which was then acquired by Blockdaemon in December 21. Blockdaemon is an institutional infrastructure provider in Web3. So we offer nodes and data and staking and an institutional MPC wallet for institutions ranging from the very conservative TradFi banking sector, think Goldman Sachs, JP Morgan, and the like, to fintechs like Revolut, PayPal, and the like, and then obviously also like Web3 native foundations and institutions like that. So let's get into it. So just to give you a very brief intro into all of the three topics, basically, so account abstraction, MPC, and MEV. In between, I'll sort of combine two of these each, so the smart accounts comparing account abstraction and MPC, and then later I'll dive into the MEV supply chain and how it connects with account abstraction. And then I'm going to combine it all and hopefully have some takeaways from different angles of different stakeholders. So account abstraction, and I have to say I'm the Ethereum ecosystem lead, so I'm always coming from the Ethereum lens of things, and I guess we're at the Ethereum conference, so we're talking ERP 4337. And there on the, let's see if this works, so on the one side you have the user, which has a wallet that is account abstraction enabled, and on the other side, on the chain, you actually have their code sitting there. And obviously 4337 is about this global entry point contract, which standardizes how we think about account abstraction. And basically, the user sends his user operation instead of a transaction into the user operation mempool, where it is picked up by bundlers in the middle here, who then bundle all the user operations, send it to the entry point contract, who calls the contract of the user on chain to verify that it's paid for gas, and then executes it. So that's sort of the very basic flow. This slide is actually from Visa, who did a POC with a paymaster, which is a way to abstract away the need for gas from the user, which is one of the great use cases that hopefully account abstractions, everyone is talking about bringing in the next billion users. So let's see about that. So you might have heard about account abstraction. If you haven't, I think there's some great talks today in the morning about account abstraction. So next up is MPC, which stands for multi-party computation. And again, you might not be as familiar with this topic. It's actually not only existing on Web3. It's actually started with Dutch sugar beet auctions and other sort of private key management. But obviously, for crypto people like us, it's always about how to protect the private key. And as you can see here on this chart from Messari, is basically the user take an input, which is private, and they will be combined with others to then form something complete that, for example, could be a private key that then signs the transactions. But none of those private parts will be revealed ever, and it's not going to exist in one place. And that's the magic, because obviously we all know about the dangers of private key management and being stolen, hacked, lost, not backed up, all these kind of things, right? And MPC basically solved this problem. Now, some say like MPC is HSM, KSM, and a multisig, but better. I'm not going to dive into all of these acronyms, but zoom in on the multisig part to just show you an example on how MPC technology is superior in that sense. Because if you see here on the left side here, you can see sort of the multisig. You have 3 locks to open the safe. So there's 3 keys and 3 locks. And One of the disadvantages is that you also have 3 transactions on chain, which means higher gas cost, and is also transparent on who participated in signing the transaction. Now, the threshold signature scheme, which is a subtopic of MPC, works a little bit different. There's only one lock. There's still 3 keys, or 3 parts of a key actually, that when combined are going to open the lock and the safe is going to open. So there's on chain, you can only see 1 transaction. You only pay 1 time gas fee. And also it hides away who participated, which might be a nice property, depending from your point of view, obviously. And it also can be upgraded. You can rotate the keys and all those kind of things for key management systems. So moving right along, now I bring those 2 together. You can probably already see that they're pretty much related. There's quite an overlap between the 2. But there's also, like, both of them make smart accounts basically elevate the crypto experience to your bank account. Right, in the sense that you can log in with your email and password, you can have 2-factor authentication, you can reset it, all these kind of things. And both technologies provide this. But account abstraction has more the focus of making the transaction smart, while MPC sort of is all about the key management and making it more secure, just to help you sort of differentiate, very high level. Then account abstraction, as we talk about it, is EVM specific, so all Ethereum mainnet, layer 2s, those kind of things, while MPC is naturally universal, so you can also apply it to Bitcoin, Solana, Polkadot, you name it, because the logic is off-chain, compared to account abstraction, where the smart contract sits on-chain. Also, obviously, very important in this regard is focusing on the trust model. So on account abstraction, you trust a lot of smart contracts, so your own wallet account, the entry point contract, all the intermediaries involved there. While on the MPC side, you trust the technology, the MPC implementation, which is highly academic, highly cryptographic, and I don't understand any of that. And obviously, the infrastructure it runs on. And for account abstraction, I guess you might be familiar with, there's some prerequisites that you need. So standardization was achieved basically by 4337. But the dApps also need to enable smart accounts, which is not always the case. And obviously, we need those paymasters and bundlers that I mentioned before, so that to make it actually work permissionlessly. And on MPC, there's nothing, because to the blockchain, it serves like an EOA, like an external owned account traditionally. And so what I already said is the main benefit for account abstraction, or one of the main benefits, is gas abstraction. And on some other levels, it's open innovation. We've seen these standardization processes to standardize smart accounts, like the Safe team is proposing some methodology of enabling interoperability of smart contract accounts. And these kind of things. And also the policies are transparent on chain, which is great for DAOs, etc. But on the other side, MPC is more geared towards the institutional use cases, because number one, it's multi-chain, but it's also sort of closed source control of this MPC core technology. And the policies and the signers are private, and that is just more appealing to institutions generally. So now we covered 2 of the 3, right? So let's dive into the third one, which is MEV, maximum extractable value. These days, it's not called the supply chain anymore. It's like a supply network. And this is the simplified version of it, basically. These days, it'll get complicated, and I'll break it down for you and start from simple and then make it complicated. So on the left side, you have the user and its wallet, who then sends a transaction to the searcher, who listens to the mempool and tries to find, let's say, arbitrage opportunities, front run or sandwich user transactions, sends the bundle to the builder. The builder makes the most profitable block of all those searcher inputs that he receives, then sends it off to the relay, and the validators subscribe to the relay in order to bring the block on chain. That's the 30-second nutshell MEV. And I mentioned already, this goes through the public mempool, right? That's the public path. And as you already can guess from the layout of this slide, there's an alternative way, which is a private path. And this is to do with private order flow. If you're familiar with the MEV space, you might have heard about it. Basically, it's trying to get an edge from the different parties in this game and in this, trying to extract the value, and also from the user side of things, trying to protect himself against this, right? Not being front run, maybe even participate and recoup some of the MEV value as a background as a service. But obviously, there's also trade-offs because it introduces trust assumptions to those parties in the middle, and also there might be an inclusion delay for your transaction. But so this is going through the private path, and it can be done via an RPC service. So these are then sent, your transaction is sent to a builder mempool, and you can see here it goes straight to the builder. Like let's say, think Flashbot Protect and the like. Or you have order flow auctions, think cow swap protocol and things like that. And so there's order flow auction mempools as well. And in that scenario, basically, it's sent to the builder, who then shares it with either all searchers or a selected few of searchers, trusted searchers, so to keep it still private in a way, but also provide the benefits that the user is looking for. So now we have those two paths. And now we introduce account abstraction into this supply network. And there you see, you add another layer to that, because now we're talking not transactions, but we talk about user operations. And again, you have the bundler user operation pools, you have the order flow auction user op pools, and then there's also a public user pool being built. I don't think it exists right now, but it'll be built, so then we have the public equivalent as well. Now, I would have loved to add MPC to this slide, but there was no room anymore. So I'm going to start anew in here. So, and to talk really about the Ménage à trois, how those three topics come together. So you can already see I arranged it sort of MPC and AA on top, because those are the related topics. They're both about smart accounts. And then we have MEV as sort of the third party. Now you can combine them for front-run protection and to recoup your MEV. That's what we said, and it's the same for either an MPC wallet or for an account abstraction wallet. So nothing terribly new here. But then you can also combine MPC with account abstraction. And one of the use cases, or the prime use case in my opinion, is actually to enable gas abstraction via a paymaster for an MPC wallet. So you have this ultra-secure MPC wallet technology, but you still might want to abstract away the gas for the user, and then you combine it with the gas abstraction on the account abstraction level. So that's that way. And it gets really fancy if you try to do it the other way and combine account abstraction with MPC. I found two use cases for that. One is in traditional MPC setups, not with the block daemon wallet. The block daemon wallet is always on-prem completely for the customer. But in many of those wallets, it's that the provider runs one MPC shard and the user runs the other shard. So that makes it a little bit difficult, or you want to have an emergency recovery system that allows you, if your provider goes down, out of business, disappears, we've seen it all, so that you can recover your funds, right? And therefore, you need to back up the shard of your provider. Now, if you want to back up that, you could argue then you're back at square one, because then you need to take care of a private key or part of a private key. You need to back it up, you need to keep it secure, you need to have access to it when needed. All these sorts of things. And if you would back up that private key share with account abstraction setup, then you can have sort of this composable security and start small. You don't have to really put it anywhere. You can add a two-factor authentication later and all those kind of things as you grow your holdings on that account maybe. And then there's even a use case which I recently discovered, that maybe you could have an AA signature share on an MPC, and that would enable like smart accounts on Bitcoin. I'm not sure how sensible that is to do, but anyway, I saw it. I have the link in the slides, and I'm going to share the slides on my Twitter afterwards, so you can dive deeper if that's of interest to you. So now that we've all these things playing together, the question is it worth it? Because obviously you add a lot of dependencies, and I would argue that this is kind of dangerous, actually. Because those third-party dependencies, they all have a risk-benefit trade-off. So I've introduced you to the benefits, but also, it does add dependency, complexity. They need to be evaluated and monitored. Like, let's say, what is the best front-run protection service out there? I couldn't answer that question, and there's probably trade-offs within that category. And then even if you found the perfect solution for you, you need to monitor this if this stays the perfect solutions over a period of a couple of years, right? So there's effort involved in that. And then all of these services or technologies, protocols, they have a business model. So if it's free, then you're the product, as they say. So you have to think carefully about that. Which basically brings me to the takeaways. So what does it mean for you? And obviously, I don't know your background, but so I try to put it into different buckets, basically. So most of you are retail wallet users, I would say. So your Deegan stuff gets more complicated, yes, but there's also more options to stay safe. So I would say enjoy responsibly and learn about these methods of keeping your trusted assets safe. That's important, and that's good, and that's what drives a lot of those innovations. Now, for institutional wallet users, which is sort of our target cohort, the complexity can be a threat to security. So for them, the risks are much higher valued or monitored, basically. So for them, it's often better to keep it simple and optimize for their needs separately. Now, if you are a wallet provider, then obviously this design space widens a lot. It has widened, and I'm sure this is not the end of the line. There's going to be new innovations that will make it even more complicated in the stack. So, and your bandwidth probably doesn't expand, right? You have a small team, and you really need to focus and zoom in on your target group needs in order to provide the best product. Now, if you are in the MEV space, and if you're, for example, a searcher or a builder, then there's new work for you to be done, basically, to watch, to not miss out. So right now, what we see is that the searchers becoming solvers or fillers. Like, let's say in the cow swap protocol or something, they call different names in different protocols, but generally, the type of work that they do is the same. So searchers become solvers and fillers, and builders become bundlers in the account abstraction world. So that's pretty clear. And why do they do that? Because the mempool and the liquidity is fragmenting across those different, the public path, the private path, the various private paths. So you need to play in as many as you can in order to have maximum exposure and maximum benefit. And for dApp builders, like I said, the good part is for MPC behaves like an external owned account on chain, so you don't need to do anything. But if you want to enable your customers and users to use account abstraction, then you need to enable EIP 1271 for smart accounts. And also, with regards to MEV, you need to build MEV-aware applications. This can actually be a business model, like let's say for a wallet, if they don't charge a fee but they recoup the MEV, it could be even a business model. But definitely need to be thinking about MEV and how it relates to your dApp. And last but not least, for infrastructure providers, there's obviously a whole bunch of new roles available, basically, like running highly secure MPC nodes, for example, running an account abstraction paymaster, or run MEV-optimized validators. So there you have it. It's it might be sexy, it might be complicated, depending on your point of view, but I would argue that it's important to follow all of those trends and understand the interactions of each of those. And I realized this was very brief, and we could talk about this a lot longer, but this could be a start of a conversation. I'm happy. You can contact me, email, Twitter, or X, or whatever, and also find me outside. But I think we also have time for some questions.
Thank you so much. We do have a couple of minutes for questions, so if there are any, we have some microphones. Yep, over there.
Hi, I was wondering if you are aware of any examples of wallet providers that use this MPC model to build in additional checks such as compliance, KYC, and maybe also security checks, like a database of all the contracts that can be trusted and avoid any transactions to malicious contracts.
I don't know any concrete names, but I assume that a lot of them do. I know it's on our roadmap for sure. So yeah, it's one of the things that you can do in MPC, sort of, as well as in account abstraction. And so I know that there's a lot of talk about this sort of in the account abstraction, and I'm sure there are going to be sort of specialized providers for these, let's say, add-on services, right? Like scam protection or whitelisting of compliance or blacklisting bad addresses, if you think about the OFAC list and things like that. And I believe, and this is also why it's exciting to see the standardization approaches for the account abstraction parts, because that would allow sort of to have a plugin module that would provide these kind of services. And I do assume that these, maybe not as standardized, because the MPC technology is a little bit more specific, I guess. But I would assume that those same providers could provide those lists. Basically, it's just lists, right? And that feed in the logic and update regularly. Could also provide that to the MPC wallet providers.
We have time for another question. Do we have another question? Yep, over there.
One of the advantages that is often also associated with account abstraction is that you can move towards signature schemes in the future which are quantum secure. How does this look for, because theoretically why most of the account abstraction currently uses ECDSA, you can change this however you want, right? How does it look with threshold signatures, right? And in general, how far is the research there? How does it play along, and what would be avenues for this?
Yeah, so to my understanding, this is pretty similar, actually. So basically, both account abstraction and MPC would allow you to use any type of signature, which could be a security problem, but it could also be opening it up for mass adoption, because if you can use the biometrics on your phone, that is, from the usability kind of view, I think to me, that would be the easiest, basically, just talking about myself. And also another sort of future benefit of that is that it could make it quantum resistant, because eventually, the signature schemes are going to break when we have quantum computers, and you want to switch that to something else, and that could be a way to achieve that, to my limited cryptographic understanding. But so, yeah, I think it's the same options and the same possibilities in both technologies.
Okay, but with NPCs, you would get a new key, right? Theoretically, again, it's more like on account abstraction, you argue your address can evolve, right? In the sense of, I know it's chain specific, but your account can upgrade towards more secure quantum security. I'm just asking because on one of the earlier slides you mentioned, right, that you can upgrade the security of your threshold signature, while actually for the multi-signature comparison it was said it's not possible. So I'm a little bit trying to understand this, how this plays into account abstraction, because there it's listed often as an advantage that it's actually that account abstraction can evolve better than MPC can evolve.
Right, yeah. I think that's something that depends on the implementation. And so if you have your account abstraction upgradable, then you could probably do that. However, that upgradability might also be a security threat. If you're, so there's at least to my understanding, there is a trade-off. I'm not an expert on account abstraction, but so I think yes, there are ways to do that, but that again comes with another trade-off. So I totally believe that the magicians can work it out, but
I have to stop, Richard. Come up front and talk to Freddy, please. I have the unpleasant task of being the timekeeper, and we have to thank Freddy at this point for his awesome talk. Thank you so much.
Sure.